As a designer, there are times when you just can't seem to get those creative juices flowing. I mean, you have a good idea, but you just can't quite come up with a look that excites you. Every now and again, I run into the same problem. So, as a Fusion 360 user, I decided I would give generative design a try to see if I could come up with something unique that, got my creative mind going again. In this video, we're going to look at Fusion 360 Ultimate and how to use generative design to come up with unique ideas. Hi, my name is Stephen Shane, the 3D Professor, and this is the 3D Professor's Lab. If you're not familiar with what generative design is, it's a way to explore design alternatives that meet a certain set of criteria. And that criteria can include weight, different forces acting on the part. Generative design uses those forces to come up with an optimized design. Now, it doesn't come up with just one solution. It comes up with many solutions that meet those design criteria. And while generative design is not strictly an Autodesk concept, Autodesk Fusion 360 has an excellent implementation of generative design. Take a look at Autodesk's website. They have a great definition of what generative design is. I'll leave the link in the description down below. You can see how generative design is being implemented by Autodesk in not just the mechanical industry, but also for architects in programs like Revit. Let's move on to the lesson. I designed a simple bracket in Inventor a few days ago, and while it's functional, it's pretty blocky. I could go in and add some fillets and chamfers, make it look nicer and more organic, but I wanted to do something a little different this time. This bracket is going to be used to hold 1x2 pieces of wood that will be used as a small shelf above my desk. I wanted to make something that was unique and made to hold at least 20 pounds. I'm going to open the shelf bracket I made in Autodesk Inventor in Fusion 360. I did this by uploading the file into my work folder and simply opening it. Fusion 360 uses Autodesk's AnyCubic to open the file. From here, I can modify it, if I want, or in this case, use it to create the geometry I'll use for the generative design study. Since this lesson is more on generative design, I'm going to go through and create the individual bodies that will be used as either preserved geometry or obstacle geometry. The preserved geometry is used to make sure that when I run the analysis, this space remains unchanged. If you look here, I have two countersunk holes. I want to make sure those holes stay countersunk and look exactly the way they're supposed to. I also have obstacle geometry that I'm going to create. This geometry will tell the analysis to avoid the space occupied by that geometry. It's important to use both types of geometry in your analysis, otherwise the generative design solution doesn't know what the parameters are when calculating the part. Here we have the bracket I made in Autodesk Inventor. What I'm going to do is use this bracket to start and create the parts I need for the preserved geometry and the obstacle geometry. Beginning with the preserved geometry, I'm going to activate a new component that was previously created. First, I'll create a construction plane that references the original model, even though the component is hidden. Click on the top face and I'll select the screw hole as the reference for the offset. Selecting the plane, I'll right-click and create a new sketch. I want to create an intersection with the original bracket. You can see that it creates the intersection where the bracket meets the plane. From here, I'm going to speed this up and just show the process of creating the different pieces I need so we can get to creating the generative design study. So hang on, This is going to go fast. Now I have all the bits I need to tell Fusion 360 what I want to generate my geometry from. This will be interesting to see what the generative design study comes up with. I'm going to save this as a new iteration. While Fusion 360 does save versions, I'm going to save this as revision 2. I'll switch over to the generative design environment. The generative design environment provides all the tools I need to generate a study. I can create a new generative design study or use the existing study to start with. I'll use the existing and go ahead and rename this study Freeform Bracket. The reason I'm calling it Freeform Bracket is I'm not going to use a starting shape for this bracket. I'm going to come over to the model component, expand the bodies, and turn the bracket off. So I'm just working with the generative design geometry. All the bodies here are going to be used for this study. Fusion 360 will come up with something, I hope something cool. First, I'll add the preserved geometry. Preserved geometry will be elements of the design that are maintained. Clicking the Preserve Geometry option, first, I'll add the preserved geometry. Preserved geometry will be elements of the design that are maintained. Clicking on the Preserve Geometry option in the Design Space panel, I'll select these elements here. And I need to select this one up here. These are going to be my preserved geometry bodies. Clicking OK, the geometry will turn green, indicating they are preserved geometry. You can also see here, I have 6 bodies. Now I'm going to select the obstacle geometry. I'll pick all these, the back plate, the screw inserts that are visible, and the 1x2 slugs. I need to pick one more screw insert. To make it a little easier, turn off the preserved geometry, then select the last body and click OK. Now there is areas where the solution will not be generated, keeping these areas clear for their intended use. Next, once I have a design condition set up, it's time to add additional criteria like structural constraints. On the Design Conditions panel, I'll go ahead and click Structural Constraints. In the viewport, I want to add a couple of fixed constraints. I want the mounting points to remain fixed in all axes. So I'll click to select the 2 faces where the mounting points will be. And I'll click OK. To apply structural load, I'm going to pick the faces I want to assign the load to. So I'll pick the 4 faces here. 1, 2, 3, and 4. I'll set the units to pound force and set the magnitude to 20. I can adjust the direction to set the orientation of the force. I have different forces available. I can set pressure and moment, or I can make it load-bearing. In this case, I want a force that's just pushing down 20 pounds. Next, I want to set the design criteria. I'll click on the Objectives and Limits. I want to set my design criteria to minimize the mass. I want to have as little material as possible, but be able to maintain the structural integrity of this bracket when I 3D print it. I do have other options. I can maximize the stiffness and give it a specific weight target if weight is important. I'll click OK. The other part of the design criteria is the manufacturing of the part. I'll open the manufacturing options. I'm only going to make 6 pieces, since I'm printing these out. I'll leave the unrestricted checked and the additive checked. I'm not going to mill this or cut it using 2-axis cutting, and I'm not die casting it. On the additive manufacturing rollout, I want to set the overhang to 55 degrees, and I'll leave the minimum thickness at 3 millimeters. Then I'll click OK to close the manufacturing dialog. I need to assign a material. If I look at the study materials, this is being made from aluminum. And the problem is, I'm not 3D printing aluminum. Since I'm 3D printing this on an FDM printer using plastic filament, particularly PLA, I need to change the material that's going to be used. I spent a little bit of time creating a new material with the material properties of PLA. While it's generic PLA, it's good enough to generate a decent solution. I'll click the Materials library, click on Favorites, and drag PLA plastic up to be the material in the study. I'm also going to right-click and delete the existing material. Then click OK to use PLA for the design study. When I run the pre-check, I'll see that the PLA plastic material I created is not supported by cost estimation for the unrestricted and additive methods. So I can either change the material or the manufacturing method. I'm going to leave the material alone because I want to solve for the PLA. One thing I'll do is save this file before I do anything else. I can do a quick preview of what this will look like when it starts to generate. You'll start seeing the preview display. This is what the solution will look like. But remember, this is just a preview and not how the final solution will look. One thing I do notice is these vertical obstacles need to be a lot longer. They need to come all the way down because I'm putting screws in to hold the wood in place. Right now, it would be difficult to get a screw and a screwdriver into the holes. I want to extend these obstacle bodies down another, 2 inches or so. Without getting out of the generative design environment, I can click Edit to edit the model. It'll stop the preview, which is fine. I don't care about the preview. Now, this is editing the model outside of the design environment. This is only going to modify the geometry in the generative design workspace. I'll click on Modify and select Press Pull. I'll select the bottom faces of these 4 objects. Once I have the 4 faces selected, I can drag those down about this far. This should be far enough. I'll finish editing the model and then run the preview again and see what happens. Based on the preview, I think we're ready. I'm going to resave the file. Now it's time to generate the study. Click Generate, and I can see it's going to cost 25 credits for this study. If you need to buy credits, you can click the Manage Cloud Credit options, go to your account, and purchase additional credits. I also see that there's a warning. I can repair it by clicking the repair link. I know that warning is the PLA plastic issue, so I'm going to ignore it. I'll select the study that I want to generate and click Generate Study. I'll send this study to the cloud and begin to process it. Once that's sent, I do have some time to cancel it and not be charged. But once it begins to calculate, I will be charged the 25 credits. So you have to be careful that you don't submit the study unintentionally. It's now processing. I'll come back in a few minutes and take a look and see what the outcome looks like. Welcome back. Now that we have some converged outcomes, I can go ahead and take a look at them and see if I want to use any of these. I want to look at outcomes that I set up for additive manufacturing. I'll open the manufacturing method and uncheck unrestricted. Having an outcome converged means that it's met its processing goals. In this case, minimizing the mass of the part while maintaining a safety factor of at least 2. Now, I have different ways of displaying these outcomes in the Explore tab. In the Display panel, I'll select the Properties view. Here, I can see additional properties for each study, including the material and the orientation it's calculated, which is important when I go to 3D print this. When I hover over one of the outcomes, I can click the checkbox. If I want to compare multiple, I can select the checkbox for several and compare them. For now, I just want to pick the outcome that will print easiest. In this case, I'll pick the outcome with the orientation in the X plus direction. This opens the Outcome View tab. Here, I can display the Model View, the Stress View, or the Export View. I also have 2 options for exporting this. I can export it to a new design, or export to a mesh. Keep in mind, exporting the design can cost 100 cloud credits. Of course, another option is to use the finished outcome simply as a guide for a new design. How you use generative design is entirely up to you. I often use generative design as a means of inspiration and don't use the exported design directly. In this case, I took the unrestricted design and rebuilt the bracket using it as the source of inspiration for a final design. With the final design completed in Fusion 360, it was time to send it to the printer. I'm using a Folgertech FT5 3D printer that's been modified with a Titan Aero hot end. After it was printed, I cut 4 pieces of good 1x2 wood and mounted the shelf above my desk. Here's the finished product, painted and mounted just below Sir Qidi. Well, I hope you enjoyed this lesson and got something out of it. Please remember to make a comment. Don't forget to like this video and hit that subscribe button. I'm Stephen Shane, the 3D Professor, in the 3D Professor's Lab. Thank you. It's time to go home.